Hi everyone, I'm Cheryl. In this exercise, we're asked to find an expression for the nth term of the sequence 2/3, 3/4, 4/5, 5/6, and so on. And after that, we're going to determine whether the sequence converges or diverges. All right, so first we need to get this expression for the nth term. This really is a matter of looking for patterns. So a couple things to keep in mind. Is the same number added over and over again? Are you squaring numbers or cubing numbers? Maybe you're taking a number and raising it to a power. Are the signs alternating? Do you have one positive, one negative, one positive again? All of these things are leading you to looking for a pattern for your particular problem. So let's take a look at the one that I have. Notice that my sequence is made up of fractions. Another way to think of this is look for patterns in just the numerator and then just the denominator. So you're breaking a more difficult problem down into two easier problems. So for the nth term, let's look first of all at the numerator. 2, 3, 4, 5, and so on. Notice that each time I add 1. So if I start with n and add 1, for my very first term when n equals 1, I'll have 2. The next time through, when n is 2, I'll have 3, 4, 5, and so on. Okay, so that's my numerator. Let's take a look at the denominator. Again, I'm increasing by increments of 1. I'm going from 3, 4, 5, and 6. So again, I think I want to add 1. But notice where I have to start. I need to start at 3. So instead of adding 1 to n, let's add 2. Because now when n is 1, my denominator will be a 3. The next time through, my denominator will be 4 because I'm adding 1 each time. So that's my expression. All right. The next part of the problem asks, does this sequence converge or diverge? To determine that, I'm going to take the limit as n approaches infinity of n plus 1 all over n plus 2. When I evaluate this limit, I'm going to divide the top and the bottom by n. So I have the limit as n approaches infinity of n plus 1 all over n divided by n plus 2 over n, which will reduce to the limit as n approaches infinity of 1 plus 1 over n all over 1 plus 2 over n. And as n approaches infinity, the 1 over n and the 2 over n both go to 0, so the entire expression goes to 1. So as I continue to take terms out, it converges, and it converges to the number 1. I hope that was helpful. Thanks.